In this video, we're going to be taking a look at the PhysX engine from Nvidia, now fully integrated into 3ds Max 2011. This physics engine helps create more compelling, dynamic, rigid body simulations directly within the 3ds Max viewport. It supports static, dynamic, and kinematic rigid bodies, also called Ragdoll simulations, and multiple constraints. So I've pulled a couple of objects from our opening scene to show you just how easy it is to use PhysX on our objects. Before I do that, though, let me switch over to wireframe view, and you can see that we've already broken up these objects into individual fragments using the Pro Cutter tool. So we've already done that step. And also notice these are exactly identical. This is on purpose, and I'll show you why in a few minutes. So to invoke PhysX, all we need to do is go to the PhysX menu, and we're going to choose Show UI. And we have a couple of different tools here, but we really only need to use the Show PhysX toolbar because we can access everything else that we need from there. Next thing we do is we just select the objects that we want to be part of the PhysX calculation. And from here, we choose Create Dynamic Rigid Body. We have three different types of solutions here, basically a dynamic rigid body, a kinetic rigid body, or a static rigid body. We'll talk about those in a second. So we'll choose Dynamic Rigid Body, and we press play, and it adds the default properties, and you can see it immediately begins showing us a simulation whenever we press play. Now, these are not keyframed yet. We haven't actually baked keys in here yet. This is really just showing us the simulation. Now let's go ahead and invoke the PhysX Tools menu. And from here, we can kind of adjust some things. We have control over whether we actually want gravity enabled, and that obviously changes the way our object works. You can see things just kind of float off into nowhere. We have the ability to have a ground plane. So if we turn off the ground plane, it'll just fall right through. And of course, we can control the amount of gravity and a couple of other parameters. So pretty straightforward, easy to use here. Changing properties is even easier, really. We use a material editor-like method for actually applying physical properties. It's called the Physical Material Editor, and you can see we have a couple of materials already applied. What I'm going to do is, before we start changing these around, I'm going to go ahead and select this object, and I'm going to create a dynamic rigid body out of it. And once that's done, you can see we now have two identical arch objects that are breaking the exact same way. Changing the physical properties using the material editor is really easy and gives us a couple of different results very quickly. So I'm going to just move this toolbar up over here. And I'm going to choose concrete as our first one. And we'll just go ahead and select the first object. And we're going to go ahead and assign that material to that selection. And I'm going to choose the other material. And we're just going to assign the rubber material to it. So we have identical objects, but two different physical materials. And we'll go ahead and press play, and we can see how different they react immediately. So it gives us kind of some variation that we need. Obviously, you probably wouldn't want to have the other one being rubber, but I just wanted to bring to your attention the different types of properties that are available to you. We can also create materials from scratch. So I'll say, create a physical material, and we have an unnamed material that has basically density, friction, and bounciness set to be the same. So we'll crank down the density. We will crank up the bounciness. And we will assign that to our currently selected object, and now it'll behave completely differently as well. You can see the other arch is really influencing it quite a bit. So creating PhysX simulations and adjusting the properties is really easy and fast, and will help bring a lot of variety to your simulations. Now let's take a look at another type of simulation called a Ragdoll. So the last thing we're going to look at is putting together a quick Ragdoll solution. I've pulled in some of the geometry from our opening shot, and you can see here we have the stairs, the arches, and we have a biped character standing at the top of the steps. So first thing I'm going to do is I'm going to select everything in the scene that I don't want to move. This is the same arch that we used before that's been all cut up, ready to be destroyed, but we're not going to do that here. We're just going to use that as a static object. So I'll go to PhysX, and I'll get the toolbar. And from the PhysX toolbar, I'm going to choose to make all of these items static rigid bodies, which means that although they'll be part of the solution, they won't really move. The next thing I'm going to do is I'm going to choose the biped. Once I have the biped selected, I can say Create Kinematic Ragdoll, and the Ragdoll is already created. We just have to add the bones. So we'll come in here, and we'll add the bones to the solution. We'll do dynamic joints, and we'll regenerate the entire biped. So now that we have the Ragdoll solution applied, we can just press play to quickly begin to see the solution. Obviously, we don't have time to tweak it up in the short amount of time that we have to take a look at it here, but we're able to get some some Ragdoll physics going in our scene that we can bake out to animation. In addition to any of these types of constraints, we have additional constraints that can be used for more complex types of solutions. Rigid constraint slides, hinges, twists, ball and socket. So quite a diverse set of solutions. So, with PhysX, we can really create a wider range of realistic dynamic simulations than we were able to before.